So my BC kids, here comes section 10.2, working with geometric series. Now back in the days of series, this is again a pre-calc topic that we don't get into very much here at our school, but nonetheless there's arithmetic series and geometric series. You might have seen it in Algebra 2. I know we didn't talk about them in pre-calc, but the difference is in an arithmetic series, you're adding a number to each term, where in a geometric series, you're going to multiply by a value. So let me give you an example. Say I have a sequence like this. First one's 4, the next term is 12, the next term is 36, the next term is 108. How do you get from a 4 to a 12? How do you get from a 12 to a 36? You can see that you're multiplying by 3. So geometric series sequences, if I'm looking at the series, it's going to have a multiplier with it. Now if I think about, sometimes I can think about what the equation would be for this. This is when n is 1, I get 4. When n is 2, I get 12. Ooh, now I got to think about what that function would be that would generate these values. It's not just times 3, because this is my my term value of 2. So 2 times 3 would be 6, but that's not what I have. I've got a 12. So I have to think about how this works. So whatever the geometric multiplied part, that's going to be in your equation. If my first term is a 4, then it has to be 4 times that value. But 4 times 3 to the first would be 12. So this is the first term. In other words, this power needs to be 1 less than that. And that's what the equation would be for this. Now let's try it. If n is 1, my first term, 1 minus 1 is 0, 3 to the 0 is 1, and then times 4 is 4. Shoo, that's good. If n is 2, then I have 2 minus 1 is 1, 3 to the first is 3, 3 times 4 is 12, and that works. Okay, and you can try some more and see if it is, but nonetheless, a geometric sequence is one in which the same number is multiplied to each term to get the next term in the sequence. The number you multiply by is called the common ratio. That's going to be important to us in this lesson. The common ratio. So, the nth term of a geometric sequence is what they're talking about in the big box, would be a sub 0 r to the n. This is the most popular one that I'm going to give next. This is the one you'll see. These are all equal to one another. Most popular is this guy where you have a sub 1 r to the n minus 1. That's like the one we just saw up above. Or sometimes they can give it with you with the first term being 2. So a sub 2, based off the second term, r to the n minus 2. Now the one that is most popular is the middle guy. Next most popular would be this first guy. So here we go. We've got 3, 6, 12, 24, 48. We have to figure out what's the common ratio. What are you multiplying by? The common ratio up here, maybe we want to make note of that. Common ratio is 3. It was whatever you were multiplying by, that multiplier piece. Where in this case, if I'm going 3, 6, 12, you can see that my multiplier is 2. So since this is being multiplied by 2, my common ratio is 2. So what does that make each term? Well, my r sub 0 would be the first term here, which is going to be, I'll show you what it is and then we'll talk about why. But it is the first term, 3 divided by my common ratio, because I have to go back 1, times 2 to the n. So let's think about this. If n is 1, my first term is 3. First term, n is 1. 2 to the first is 2, which cancels with the 2 down here, gives me the 3 that I want. So it seems a little odd because you're going backwards, but that's my first term. The next one would be 3 times 2, my common ratio, to the n minus 1 power, just like it is up here. This one would be the second term. A sub 2 is 6. So a sub 2 is 6, r to the n minus 2 power. In our case, our r is 2. My bad. Let me put a 2 in here and replace it. Times 2 to the n minus 2 power. So if n is 2, 2 minus 2 is 0, 2 to the 0 is 1, 1 times 6 is 6, and that's my second term. So all of those are equivalent ways to write this particular sequence. How about if I have something like this where it decreases? It's not an increaser. I still need to figure out my common ratio. What am I multiplying by? This case it's going to be a fraction, right? Because it's getting smaller. So to go from 25 to 5, I'm multiplying by 1/5. So there's my common ratio. So this time I have to take my terms and figure out what they're going to be for the formulas. This one's a little bit trickier. So I have 25, but I have to divide it, just like I did up here. I divided that first term by my common ratio. First term divided by 1/5 gives me 125. And then it would be times my ratio, 1/5 to the nth power. Second one just takes the first term, 25, multiplies it by the common ratio to the n minus 1 power. And then the third one takes the second term, 5, and I have it times 1/5, my common ratio, to the n minus 2 power. They're all equivalent ways of writing the same thing. It's just, again, the middle guy is the most popular. The one that you'll see the most is probably the one that makes most sense too. So the sum, an infinite, this is an example of an infinite geometric series. Why? Because it goes to infinity. It's a sum that goes to infinity. Notice this time that my first starting term is a 0. So my first term is actually 0 for my n, which leaves me with r to the 0, which is 1, which leaves me with the first term of just an a. Next term, if r is 1, then I have a r to the first power. Next one, if r is 2, then I have a r squared, or to the second power. If I go and keep going, it's going to keep on getting bigger, making a r to the nth power, whatever that would be. Could be infinity, could be something smaller. So geometric infinite series converge, the whole concept again of convergence. They converge. A geometric series with a ratio of r diverges when the absolute value of r is greater than 1 or equal to 1. But if the absolute value of r is less than 1, not equal to, then the series converges. So here's your formula. You're going to take a r to the k, that's your first term, and you're going to divide it by 1 minus the common ratio, r being the common ratio. So let me say over here, r equals the common ratio. Common ratio. And this guy, your numerator, is your first term. They're going to refer to it as ar to the k, but really it's your first term, whatever that might be. So if I want to know what this sum is, all I need to do is take the first term and divide it by 1 minus the ratio, where ar to the k is the first term, as I said. So sometimes you have to manipulate these to be in the right format so you can figure out what r actually is, and that's what these first couple examples are talking about. So if I'm looking at this, I need to have it separated so that I've got just a single fraction that's my r. So let me show you how I would do that in a problem like this. I'm not going to change the sum any, 0 to infinity, but I'm going to break apart the fraction so that I would have the 3, the numerator, and then that would leave me with 1 over 4, right? Well, that 1 over 4 is to the nth power. See how it's now in this format of a r to the k, a r to the k power? That means that my r is 1/4. I'll come over here. R is 1/4. And this works because 1 to any power is still 1. So that's why I can break it apart and not just put the 4 to the nth power here. I can make it 1/4 because 1 to the any power is 1. And the 4 would still be changing as it should. So my r equals 1/4. And so I'm going to look at that. My r is the absolute value of r, 1/4, is less than 1. I'm comparing it with 1. This is my comparison up here. So since it's less than 1, I know that this thing is going to converge. So I can literally figure out the sum for this thing by taking the first term, ar to the k. In other words, for us, it's ar to the 0. So a is this number, 3. R we said was 1/4, and it's being raised to the 0 power. 3 times 1 is 3. Lets me put together my formula. And my formula says take ar to the k, 3, divided by 1 minus my r of 1/4. Well, that would be like 3 divided by 3/4. 3 divided by 3/4, keep change flip. I get an answer of 4. And so it converges, and you know that that sum is going to be 4 for this one. Example 2. This is kind of interesting. Another way to algebraically break these apart. It's a whole thing of trying to figure out if you can put it into this format, ar to the k. And you can for this one too, but notice that it's kind of different. So I'm going to break it up this way. I'm going to take the top and think about my exponent rules. This would be the same thing as if I took 3 to the n plus 3 to the first. Right, I can break it apart because I would add the exponents for that with like bases. So can you see where it's going to go next? 2. This one starts at 2. 2 to infinity. That's going to be, well, let me make room here. That's going to be 3 to the n, 4 to the n. They come together. 3/4 to the n. That's going to create my ratio, my r. And then what am I left with? If I take those and put them together, I'm left with a 3 to the first. Now it's in the right format. Now I know that my r is 3/4, which means that the absolute value of 3/4 is less than 1, therefore it converges. I can use my sum to calculate the rest, and my ar to the k for this case is going to be, now watch what it starts with. This one starts at 2. So that's the number you have to put in for your k. My a is 3, my r is 3/4, and my k is 2. All right, let's think about this. 9/16. But the 9 gets multiplied by another 3, gives me 27/16. I can do the same thing, take the first term, 27/16, and divide it by 1 minus my r of 3/4. I just went horizontal automatically. All right, so I have 27/16 times 1 minus 3/4 is 1/4, but when I flip it, it's 4/1. And so I end up with the 4 and the 16 reducing, and I get 27. For lack of space, I'm not showing you all the steps, but there it is, 27/4. All right, a couple more examples. So flip the page. Number 3. For what values of r does the infinite series, if I can speak, of the sum going from 0 to infinity of 17r to the n equal 23? All right, so that means that you need to know what your first term would be. You need to know what ar to the k is. Well, that would be 17 r to the 0 power. Right, 17r to the 0 power. R to the 0 power is 1, so I get 17. I don't know what r is. That's what they want me to find. So remember, I'm going to that formula that says take the first term, that's this guy, 17, divided by 1 minus r. And they told you that it has to equal 23. So there it is. There's your setup. So it's just a matter of the algebra to be able to do that. If I cross multiply, 23 times 1 is 23. R times 23 is 23r is 17. And look how simple this is going to be. If I take this and subtract the 7, actually let me go this way. Subtract the 23, I get negative 6. So negative 23r equals negative 6. And r is therefore 6 over 23. That's the value of r. Last example, calculator active. Let's see how this goes. If this is your sum, then what's f of 7? All right, let's figure this out. I need to know what ar to the k is. First term. I know that my x value is 7, so that's going to be plugged in right here. So that's going to give me the sine squared of 7/3, and I need to then cube that because it's the beginning term is a 3 this time is my first term. And so I go to my calculator, and you're going to put this right into your calculator, make sure that you're in the radian mode. Sometimes it is easier. Actually, this is also going to be raised to the 6th power, squared and then cubed. So you could do that to make it a little simpler. But nonetheless, you're looking to get out 1.142935. First term. Now your r term is going to be this piece inside here. It's just the sine squared of 7/3. That comes out to be 0.5229 or 52285. This is just plugging it right in the calculator, so you can do that. I got faith. All right, so then we're going to put it in the formula. We have our first term goes on top, 0.142935 over 1 minus my r. And when you calculate that out, you get a final value of 0.2995. That's your final best. Okay, we are going to pick a couple from our from the practice problems. First one's number 4. They say find the values of each infinite series. So in other words, they want to know what the first term divided by 1 minus r is. So that's going to be our same formula we've been looking for. We need to know the first term, and we need to know an r. First term is when I put a 1 in for n. So I'm going to have e over pi to the first power, or e over pi. And then my r is going to be, it's already in the format, isn't it? That's pretty cool. Remember, e is a constant, pi is a constant, so it's just e over pi. Now, e over pi, let me think about this, about converging or diverging. Although they're not asking for it here, they're going to, so might as well practice it. Is e over pi, the absolute value of that, greater than 1 or less than 1? E is 2.718, yada yada. Pi is 3.14, yada yada. So small over big, that makes this be less than 1. And so therefore I know, that it converges. All right, let's figure out the value of the infinite series here. So the value is going to be my first term, e over pi minus 1 minus r, which is also e over pi. Now there's a trick to this. Like you're looking at that, that's a complex fraction, and ain't nobody liking that, especially Mr. AP. But if you multiply by pi, everybody by a pi, what's it going to look like now? E over pi times pi is just an e. 1 times pi is pi. E over pi times pi is just an e, and now you've simplified it down to be a single fraction without a big deal. All right, next one is number 7, also involving pi's and e's. And then I think it's number 10, and I think that's it. So just two more. Oh, no, 13. I was kidding. All right, 7's next. 7, I have to divide this guy up. It's going to take a bit for me to get to where I need to be, especially to figure out what the R is. So let me do the ARK first. AR to the K, first term. Well, R is 0, N is 0, so it's going to be -1 to the 0, and then I'm multiplying that by pi over e to the 0 plus 1. Well, this is 1. This is 1 for e to the first, so that my answer comes out to be pi over e again for my value for the first term. But getting to see what the ratio is for this one takes a little doing. So I know I have a fraction. I can still have the same sum. Kids make fun of me for my summation sign. I'm sorry, I'm not very good at those after all these years, right? All right, so I'm going to make a fraction. And in my fraction, I have a -1 to the n. That's this piece. I have a pi. That's my top. In the bottom, if I break this up by exponent rules, I have an e to the n, and I have an e to the first. You can kind of see how this is going to create your ratio. So here's what it actually is going to look like when you finish putting the summation together. You're going to have an a value of pi over e, and then that's this part. And then you're going to have a ratio that is 1, actually -1, over e being raised to the nth power. So you see how I've manipulated that to an ARK kind of situation, which tells me that R is -1 over E. Well, -1 over E, if I take the absolute value of that, is that greater than 1 or smaller than 1? And we can see obviously it's smaller than 1, so I know it's converging. And let me put my formula together. I take the first term, pi over E. I divide it by 1 minus the R value, -1 over E, or pi over E times 1 plus 1 over E. What am I going to multiply this time to get rid of the complex fraction? And I hope you're seeing E times E. Everybody gets multiplied by E. Gives me a pi. 1 times E is E. 1 over E times E is plus 1. And there you go. That's your answer. So number 10 is like the calculator question we just had that I did with you a few minutes ago. I need to know AR to the K. I'm not reading that right. I'm saying it right. AR to the K. K is 1. So I have a function here that would be, I'm plugging in a 3 for my x, and I'm plugging in a 1 for my n. So it's going to look like this. I will have the sine squared of 2 times 3. I'll leave it this way now. And I'm raising that to the first power. So in other words, I want to know what's the sine squared of 6. Go to my handy dandy calculator. I say, okay, guys, what is it? And they tell me it's 0.078073. Well, what's your R? Your R is just this value inside without it being raised to the nth power. So your R is the sine squared of 6, which is the same answer you just got. Check that out, 0.078073. Put it in the sum formula. First term, 0.078073 over 1 minus 0.078073. And that gives you a final value of 0.0846. Okay? All right, now here comes, let me double check and make sure it's the last one. Yeah, here comes the last one. Number 13. I just found that the wording of this, like what they gave you, was slightly different than things we've seen. So number 13, we're going to end with this guy. Consider the series of the summation going from 1 to infinity of a sub n. If a sub 1 is 32, and a sub n sub n plus 1, I can't say that, can I? Over a sub n is 1/4. For all the integers where n is greater than 1, then what is a sub n going from 1 to infinity for this thing? What's the function? So here, what are they giving me? Like, you're looking like this going, a lot of things are depending upon what the first term is, right? And what your r is. They're the two big questions as you're doing these problems, right? So they're telling you right here, a sub 1 is 32. Well, that's your first term. And they're saying that the ratio, this is actually a different way of writing the ratio. This is all saying that your ratio is 1/4. And if you can decipher that from that verbiage, then the rest of this is pretty easy, because all you need to do is to find a sub n is to put it in your formula. Take the first term, 32, divide it by 1 minus r, and there it is. So you just finish it out. 32 over 3/4 is 32 divided by 3/4 times 4/3. And so you end up with 128/3. And that's what a sub n would be with those conditions. All right, kids, that takes care of section 10.2 on geometric series and summations and such. So your homework is 1 to 16, whatever we didn't do, and I will see you in class, but email me if you've got any questions. Bye.